generate uniform distribution from 0 to 20. That's what we did before, right? And then we do the same thing. So this 30 is all from the same population. Exactly same distribution, follow same distribution. So we call it identical. It's identical random variables. And then we either say first, say how about the of the first 2 from A to first 5 to A to E2. Okay. So if I pick 5 of them versus I pick 30 of them from exactly same population. So I can do for 2,000 times. Now I have the data set. The next thing is I calculate the average. Okay. So I need to generate 2,000 average. So average of 5. So I can follow the same approach. I give a mark of the end of my data. And then I copy. When I paste, I use Shift, Control, and down key. So automatically select to the end. Yeah, I hope you can find a more efficient way. Now we call X bar indicate that means sample average. I use -5, that's the average of the first 5 data points. My sample size is 5. Every time I pick up 5, this data value from the exactly same population, and then find what's the average. This is the sample size 30. Now we can fill in this table to see. So this is the average of the So for this one, since we don't need this part. Let's skip this one. What we are very interested is the average of your X bar. So X bar is the AF and AG column. AF2 to 2000. This is average. We want the population. Did I see the population mean? No. Population mean. And population variance. Okay. So we know the population mean, population variance, that's B minus A squared divided by 12. Okay. So you look at the average, okay, it's almost the same as the population. Each individual, your X, the mean, right? And the variance is also, so we can see the variance. It's from AF2 to AF. Variance, sample variance. This is from AG2 to AG to somewhere. So the variance are different. So the sample size is larger, the X bar variance becomes smaller. So we can plot this to see the histogram looks like. We want one histogram. This is X bar 5 sample. Okay. Why is it so big? Smaller. Okay. I want to, I want to cut paste to the top of the file. Otherwise, it's here. And also I can select the data. Go back. So this one is X bar. We have 30. So every time the average of 30, every time the sample size is 30. So the average looks like this. Looks like a normal shape. So this one, you see this bar is go from 6.7 to 13, so it's more narrow. But for the first one, if sample size 5, it goes from 1 to 18, it's like 17, so it's more wild. Okay, so the variance here, so it's down to one of our findings today. If your X is a simple random sample, like what we did from a population, so this X1, Xn, all random variable, but they all follow exactly same population. So this time, if you take the average of this sample, the average mean will be equal to your individual X mean. And the variance will be individual variance divided by sample size. So for this one, if I is individual variance divided by sample size, and sample size 5, see, it's quite close, right? So we verify our formula. So for this one, the individual variance divided by sample size. So it's very close. In other words, you look at your average. The size is larger. This average value more concentrate, right? We divide it by sample size. The variance, the population variance divided by sample size. That's the theoretically your average